In this video, I'm going to go over a couple practice problems from our pH and concentration worksheets. They are pretty easy. You just need to really see how it works in the beginning to get started. So the first column, so let's do one of these. It says, here's your pH concentration, right? So I'll do the third one down. And so if you notice, this is the concentration of the pH in molarity. And if you watch the video, the exponent is the pH. The negative sign doesn't matter. Okay, so this is times 10 to the negative 11, molar concentration of H+. Well, that's the pH. Now, in the videos that I included, my video, I talked about just the bare minimum. In some of the other videos that I didn't make, they might have gotten a little bit more advanced than we needed, talking about calculating pH and pOH. This is as much as you're going to need. You're not actually going to have to do the calculations. You're just going to have to recognize if this is the molarity concentration of H+, the exponent is the pH. For this column, it's just saying take this out of scientific notation. So point. There we go. There is that number out of scientific notation. Next column, is this pH acidic, basic, or neutral? Well, above 7 is base. So it's basic. Next column just gives you an indicator, and then you're going to tell me the color. Meaning, phenolphthalein at pH 11, what color would it be? For that, you go to table M, and you say, okay, phenolphthalein changes from colorless to pink between 8 and 9. So that means if it's above 9, it's pink. If it's below 8, it's colorless. And in between, it would be a mix of the two, which would be light pink if you mix the two together. I believe I have a video on this where they're doing a titration, and they actually show you the colorless and the light pink of phenolphthalein. I'm not sure if it's on this assignment or if it's in the titration assignment, but you will get to it eventually. So there's that distinction. So since we're at pH 11, that's above 9, then we are going to be pink. That's how you do the whole first page. Second page, it's pretty simple. I'll do one, you're gonna do the rest. So we can do, I guess, brome cresol green. Looks like a good one, or we'll start with the first one, litmus. So here's my pH change. It goes from 4 to 6. So you should know that for every number the pH changes, the concentration changes by 10-fold. So in other words, if you go from 4 to 5, that's a 10 times decrease in the H+ concentration. If you go to 5 to 6, that's another 10 times decrease. If you go from 4 to 6, well, that's 10 times 10. So it is a 100-time decrease in the H+ concentration. What that means, it doesn't mean your pH went down. It means the H+ is now less concentrated by 100 times at 6 than it was at 4. Okay, now you could also frame this in terms of OH minus, meaning if the pH went down by 100, then that also means that the H+, you could say, goes up by 100. So they're always doing opposite things. And then the next question would be, let's see, if we did 7 to 4, for example, well, that's becoming more acidic by 3 numbers. So that's 10 times 10 times 10. So this is 1,000 times increase in H+. In other words, pH 4 has 1,000 times more H's per concentration, or per molarity, I guess you could say, than pH 7. Now, for the color change, it's pretty simple. You could have one color as your answer, you could have 2 colors as your answer, or you could have all 3 colors as your answer, and here's the reason why. Let's take a look at table M. So table M for litmus says litmus changes from 4.5 to 8.3. So at 4, litmus would be below 4.5, it would be red. But when it gets to 6, it will have crossed over the 4.5 mark and be between the 2 color options. So it would be red and blue mixed together, which would be purple. Right? Red and blue make purple. Pretty sure. I think so. So there's my middle color. Now, if this said, okay, what if it went to 9? Well, then it would have gone all the way past 8.3, and then it would turn red to purple to blue. So to do bromethymol blue for litmus, bromethymol blue changes between 6.0 and 7.6. So at 7, it's still in the middle. So yellow and blue would be green. And then it's going below 6, so that means it's going to turn yellow. Now, a common question would be like, well, how do you know if it's only one color? Well, it's simple. For bromethymol blue, let's say I said, what's the change if you went from like 1 to 2, or from 2 to 3, or from 3 to 4? Well, they're all below 6, so it's just going to stay yellow because it didn't cross over the 6 barrier. If the change went from, let's say, 8 to 9, or 9 to 14, it doesn't make a difference how big it is, since those numbers are all over 7.6, it would just be blue. So there'd be only one color, there'd be no change. And then if the pH went from, let's say, 1 to 14 and it did the whole scale, well, you would see it would start out yellow, it would turn green for a really short amount of time, just this middle range, and then it would turn blue again. It would turn to blue once it went over 7.6. So you'd have all 3 colors because you hit the entire range. So that's how you do it. There's a couple questions on the bottom. They're pretty basic. If you use your notes, you'll know what they are.